To truly understand Chainlink, we need to go back to the moment when smart contracts first captured the imagination of the crypto world. In theory, smart contracts were supposed to be unstoppable pieces of code that could execute agreements automatically, without trust, without intermediaries, and without human interference. They promised a future where code replaced lawyers, banks, and bureaucratic middlemen. And for a while, that vision felt almost magical. But very quickly, a quiet and uncomfortable truth surfaced. Smart contracts, for all their elegance, were blind. They lived entirely inside the blockchain. They could see wallet balances, transaction histories, and on chain states. But the moment they needed information from the real world, they hit a wall. A lending protocol couldn't know the price of ETH in dollars. An insurance contract couldn't know whether it rained or not. A prediction market couldn't know the outcome of an election. The blockchain was a closed universe, perfectly deterministic, yet completely disconnected from reality. This limitation became known as the Oracle problem, and it wasn't a minor technical inconvenience. It was a fundamental flaw that threatened the usefulness of smart contracts at scale. If a smart contract relied on a single data source, that source became a point of failure. If that data source was manipulated, delayed, or simply wrong, the entire contract could behave incorrectly while still being technically correct on chain. In a system that was supposed to eliminate trust, developers were forced to reintroduce it through centralized data providers. This is the moment where Chainlink enters the story, not as a flashy token or a speculative idea, but as a necessary response to a structural weakness. Chainlink didn't try to reinvent the blockchain. It didn't try to compete with Ethereum, Bitcoin, or any Layer 1 protocol. Instead, it asked a far more practical question. How do we allow blockchains to safely interact with the real world without breaking their core promise of decentralization? The answer was not a single oracle, but a network of them. Chainlink proposed a decentralized oracle network where multiple independent nodes fetch data from multiple independent sources, aggregate that data, and deliver a final result to a smart contract. No single node could decide the outcome. No single data provider could manipulate the system. Trust was distributed, quantified, and incentivized rather than blindly assumed. This shift was subtle but profound. Instead of asking, "Can I trust this data source?" the question became, "How much would it cost to corrupt this system?" And that is a very different way of thinking. Chainlink reframed data integrity as an economic problem rather than a moral one. If attacking the Oracle network costs more than the potential profit, rational actors are disincentivized from even trying. What made Chainlink especially compelling was its neutrality. It wasn't tied to one blockchain, one application, or one ideology. It positioned itself as middleware, an invisible layer that connects blockchains to external data, APIs, legacy systems, and eventually even other blockchains. This neutrality allowed it to grow quietly, while the rest of the crypto world chased narratives, hype cycles, and short-term trends. At the same time, Chainlink understood something that many early crypto projects underestimated. Data is power. In traditional finance and tech, whoever controls data controls outcomes. Prices, interest rates, risk models, and automated decisions all depend on reliable information. By focusing on data delivery rather than user-facing applications, Chainlink aimed to become foundational infrastructure, the kind you don't notice until it's gone. This approach required patience. Infrastructure is rarely celebrated. When it works, it's invisible. When it fails, everything breaks. Chainlink embraced this role fully. It didn't market itself as revolutionary consumer technology. Instead, it spoke the language of reliability, security, and long-term guarantees. It targeted developers first, understanding that real adoption starts with builders, not speculators. As decentralized finance began to emerge, the importance of this design choice became painfully clear. DeFi protocols didn't just need price feeds. They needed them to be accurate, tamper-resistant, and resilient under extreme market conditions. A single bad data point could trigger mass liquidations, cascading failures, and systemic risk. In that environment, the Oracle wasn't a peripheral component. It was a critical piece of financial infrastructure. Chainlink was built for that responsibility from day one. Its existence is rooted in a simple but often overlooked reality. Blockchains alone are not enough. They are powerful settlement layers, but without a secure bridge to external information, they remain isolated systems. Chainlink became that bridge, not by weakening the trustless nature of blockchains, but by extending it beyond the chain itself. Understanding Chainlink begins with recognizing that it solves a problem most people don't see until it's already caused damage. It doesn't promise utopia, it promises correctness. And in a world increasingly run by automated systems, correctness may be the most valuable promise of all. This is where the story truly begins. Once you understand why Chainlink had to exist, the next natural question is how it manages to do what it claims without recreating the very trust problems blockchain was meant to eliminate. The answer lies not in a single mechanism, but in a carefully layered architecture that treats data as something that must be earned, verified, and economically secured. At its core, Chainlink is not an oracle. It is a network of oracles. This distinction matters more than it sounds. A traditional oracle is just a bridge that brings external data onto the blockchain. If that bridge fails, lies, or is compromised, the smart contract has no way of knowing. Chainlink replaces this fragile bridge with a decentralized system where no single participant is trusted by default. Every piece of data becomes the result of collective agreement rather than individual authority. The process begins when a smart contract requests external data. That request is not sent to one source, but to the Chainlink network. From there, multiple independent nodes respond. Each node is operated by a different entity, often professional infrastructure providers, data specialists, or security-focused operators with reputations and capital at stake. These nodes don't simply forward data blindly. They retrieve information from multiple high-quality data sources, such as exchanges, data aggregators, and institutional APIs. The results are then aggregated using predefined logic, filtering out outliers and anomalies before delivering a final answer to the smart contract. What emerges is not the truth in an abstract sense, but the most economically reliable version of reality that the system can produce. This is where Chainlink's design becomes especially elegant. It assumes that nodes are self-interested. It doesn't require them to be honest out of goodwill. Instead, it aligns honesty with profit. Nodes are rewarded for delivering accurate data and penalized for misbehavior. Over time, reputation systems and staking mechanisms further reinforce this alignment, making reliability a competitive advantage. In other words, Chainlink doesn't fight human nature. It leverages it. Another critical insight behind Chainlink is the separation between on-chain and off-chain computation. Blockchains are excellent at enforcing rules, but terrible at heavy computation and data retrieval. Chainlink pushes complex tasks off-chain, where they are faster and cheaper, while using the blockchain only to verify results and enforce incentives. This hybrid approach allows Chainlink to scale without overloading the underlying blockchain. It also opens the door to far more than simple price feeds. Random number generation, API calls, cross-chain communication, and complex data processing all become possible without sacrificing security. One of the most misunderstood aspects of Chainlink is decentralization itself. Many assume that simply having multiple nodes is enough. Chainlink goes further by emphasizing diversity. Different operators, different geographic locations, different software stacks, and different data sources all reduce correlated risk. The goal is not just to avoid a single point of failure, but to make coordinated attacks economically and logistically impractical. This is especially important during moments of market stress. History has shown that the most dangerous failures don't happen during calm conditions. They happen during volatility, when incentives to manipulate data are highest. Chainlink's architecture is designed with these worst-case scenarios in mind. If one node fails, others continue. If one data source reports an anomaly, it is diluted by the rest. The system degrades gracefully rather than catastrophically. Beyond data delivery, Chainlink also introduces a powerful idea: verifiable computation. Smart contracts don't just need information. They need assurance that the information was produced correctly. Chainlink allows developers to specify how data should be sourced, processed, and validated, turning external inputs into something closer to cryptographic truth. This transforms what smart contracts can do. They are no longer passive recipients of information. They become active participants in a larger computational system that spans both on-chain and off-chain worlds. Chainlink acts as the coordination layer that makes this interaction reliable. Importantly, Chainlink was designed to be blockchain agnostic. It does not assume that one chain will rule them all. Instead, it treats blockchains as endpoints, each with their own strengths and trade-offs. This flexibility allows Chainlink to support Ethereum, Layer 2 networks, sidechains, and entirely different ecosystems without rewriting its core philosophy. This design choice reflects a deeper worldview. Chainlink doesn't bet on winners. It builds for inevitabilities. As long as smart contracts exist and as long as they need external data, the Oracle problem will exist. Chainlink positions itself as the long-term solution to that problem, independent of which blockchain narratives dominate in any given cycle. Understanding how Chainlink works reveals something subtle but important. It is not trying to be exciting. It is trying to be correct, resilient, and boring in the best possible way. Every design decision prioritizes reliability over novelty, incentives over promises, and systems over slogans. And that is precisely why so much of the crypto ecosystem quietly depends on it. In the next part, this dependence becomes impossible to ignore as we explore how Chainlink embedded itself into DeFi, NFTs, and the broader Web3 landscape without ever demanding the spotlight. By the time decentralized finance began to take shape, the Oracle problem was no longer theoretical. It became painfully real. Protocols were locking in billions of dollars, automated liquidations were happening in seconds, and a single faulty data point could trigger cascading failures across the entire ecosystem. In this environment, data was no longer just information. It was systemic risk. This is where Chainlink quietly became indispensable. Most people interact with DeFi through interfaces, yields, and tokens. What they don't see is the constant stream of external data feeding these protocols. Every lending platform needs accurate price feeds to determine collateral value. Every derivatives protocol needs real-time market data to settle positions. Every stablecoin needs reliable references to maintain its peg. Without trustworthy oracles, these systems don't just malfunction. They collapse. Chainlink emerged as the default choice, not because it was trendy, but because it worked when things went wrong. As market volatility increased, especially during extreme events, the resilience of Oracle infrastructure was tested repeatedly. Many early solutions failed under pressure, relying on single sources or fragile assumptions. Chainlink's decentralized design proved its value precisely in these moments. When markets moved violently, when congestion spiked, and when incentives to manipulate prices were at their highest, Chainlink feeds continued to function. Over time, this reliability turned into trust, not blind trust, but earned trust. Major DeFi protocols began integrating Chainlink not as an experiment, but as a foundational dependency. Once integrated, removing it became unthinkable. The cost of failure was simply too high. This created a powerful network effect. As more value flowed through Chainlink-secured contracts, the incentive to maintain and improve the network grew stronger, attracting more professional node operators and higher quality data sources. But Chainlink's role didn't stop at DeFi. As NFTs and blockchain-based games gained popularity, a new class of problems emerged. These applications needed randomness, real-world event triggers, and external inputs that couldn't be predicted or manipulated. Chainlink's verifiable randomness function addressed this need by providing cryptographically secure randomness that could be independently verified on-chain. This may sound abstract, but its implications are profound. Fair NFT distributions, unpredictable in-game events, and trustless lotteries all depend on randomness that no single party can control. Without this, decentralized applications quietly reintroduce trust in the most sensitive places. Chainlink made unpredictability verifiable. Web3, in its broader sense, pushes this idea even further. It envisions a world where smart contracts interact not just with crypto markets, but with real-world systems. Supply chains, insurance, identity, IoT devices, and enterprise workflows all require reliable external data. In these contexts, the Oracle is no longer a supporting actor. It becomes the interface between code and reality. Chainlink approached this expansion methodically. Instead of chasing consumer adoption, it focused on partnerships, standards, and tooling for developers and institutions. It spoke the language of engineers, risk managers, and system architects. This made it uniquely positioned to bridge not just blockchains, but cultures. Open source crypto on one side and traditional enterprises on the other. One of the most striking aspects of Chainlink's growth is how little it demanded attention. It didn't need users to love it. It needed developers to trust it. And once that trust was established, usage compounded naturally. Each new integration increased the cost of switching, reinforcing Chainlink's position as infrastructure rather than a replaceable service. This is also why Chainlink avoided being tied to a single narrative. While some projects branded themselves as DeFi tokens or NFT platforms, Chainlink remained deliberately abstract. It was a data layer, a coordination layer, a reliability layer. These are not concepts that trend on social media, but they are the ones that endure. As cross-chain ecosystems began to form, Chainlink's relevance only increased. Different blockchains, each with their own environments and assumptions, still needed a common standard for external data. Chainlink's blockchain-agnostic approach allowed it to serve as connective tissue between otherwise isolated systems. In many ways, Chainlink functions like the plumbing of Web3. You don't notice it when it works, and you can't build without it. It doesn't define user experience directly, but it defines what is possible behind the scenes. And as more real-world value flows into decentralized systems, the importance of this invisible layer only grows. Understanding Chainlink's role in DeFi, NFTs, and Web3 reveals a deeper pattern. The most critical components of an ecosystem are often the least visible. They don't inspire excitement, but they enable everything else to exist safely. In the next part, we turn to a subject that inevitably attracts attention, the Link token itself, and explore how economics, incentives, and long-term vision come together to support the system without reducing it to speculation. When people first encounter Chainlink, it's often through the Link token. And like most things in crypto, the token tends to attract attention for the wrong reasons. Price charts, speculation, and short-term narratives often dominate the conversation. But if we want to understand Chainlink honestly, we have to step away from market noise and look at what Link is actually designed to do. Link is not a governance token in the traditional sense, and it is not a shortcut to ownership or control. It is an incentive mechanism. Its primary role is to align economic behavior across a decentralized network of independent actors who have never met and do not need to trust one another. In Chainlink's system, data has value, but only if it is correct. Node operators are paid in Link for providing Oracle services. This payment is not arbitrary. It reflects the importance of the data being delivered and the level of risk involved. A price feed securing billions of dollars requires stronger guarantees than a simple API call. Link becomes the unit through which these guarantees are priced and enforced. As the network evolves, staking introduces an even deeper layer of accountability. By locking up Link as collateral, node operators put real value at risk. If they act maliciously, provide incorrect data, or fail to meet performance standards, they can be penalized. This transforms good behavior from a moral expectation into a financial necessity. What's important here is that security scales with usage. As more value flows through Chainlink-secured smart contracts, the economic weight behind Oracle services increases. This naturally raises the cost of attacking the network. In this sense, Link is not meant to create artificial scarcity or hype. It is meant to make honesty expensive to break. This design reflects a long-term mindset. Chainlink does not assume that participants are altruistic. It assumes that incentives must be continuously reinforced. Markets change, motivations shift, and systems must remain robust even when conditions are hostile. Link exists to ensure that the Oracle layer remains trustworthy regardless of sentiment. Another overlooked aspect of Link is how it reinforces neutrality. Because Chainlink serves many blockchains and applications, it cannot favor one over another without undermining its own value. Link, as a shared economic layer, encourages behavior that benefits the network as a whole rather than any single ecosystem. This neutrality is essential for adoption at scale. Chainlink's vision extends far beyond crypto-native applications. It aims to become a universal standard for smart contract data, one that enterprises, financial institutions, and even governments can rely on. For these actors, ideology matters less than guarantees. They care about uptime, accountability, and predictable behavior under stress. Link enables these guarantees without requiring permission. This is where Chainlink's long game becomes visible. Instead of optimizing for rapid user growth or flashy features, it invests in reliability, partnerships, and standards. It positions itself not as a disruptor seeking attention, but as infrastructure seeking integration. This approach is slower, but it compounds. As traditional systems begin experimenting with blockchain-based automation, they encounter the same Oracle problem that DeFi did. How do you connect deterministic code with messy real-world data? Chainlink already has an answer, and more importantly, a track record. Link becomes the economic glue that allows these experiments to scale without introducing unacceptable risk. There is also a philosophical layer to this design. Chainlink recognizes that trustlessness is not absolute. It is something that must be engineered, measured, and paid for. Link is the mechanism through which trust is priced and maintained in a decentralized context. Seen through this lens, Link is not a bet on hype. It is a bet on usage. Its value is tied not to narratives, but to how much economic activity depends on the correctness of data. The more automated systems rely on Chainlink, the more critical its incentive layer becomes. This perspective changes how we think about success in crypto. Instead of asking which token will outperform in the next cycle, it asks which systems will still be necessary in 10 years. Chainlink is built for that horizon. In the final part, we move away from architecture and economics and into something more personal. After watching Chainlink evolve through multiple cycles, what does it represent on a human level? And why does it embody a kind of value that is often overlooked in a space obsessed with speed and spectacle? After spending enough time in the crypto space, you start to notice a pattern. Projects rise loudly, fueled by bold promises and powerful narratives, and then just as loudly fade away. White papers change, roadmaps are rewritten, and communities move on to the next story. In that constant motion, it becomes difficult to tell the difference between momentum and meaning. Chainlink never fit comfortably into that cycle. From a personal perspective, watching Chainlink over the years has felt less like following a startup and more like observing infrastructure being poured, layer by layer, underground. It was never the most exciting conversation at the table. It rarely offered the emotional highs that traders chase. And yet it was always there, quietly doing the work that allowed everything else to function. That consistency leaves an impression. What stands out most about Chainlink is its refusal to pretend that complexity can be wished away. While much of crypto thrives on simplifying reality into slogans, Chainlink leans into the uncomfortable truth that real-world systems are messy. Data is imperfect. Incentives matter. Security is expensive. Instead of ignoring these facts, Chainlink builds around them. This approach resonates deeply with anyone who has lived through multiple market cycles. Over time, you learn that survival in complex systems has less to do with brilliance and more to do with resilience. Chainlink embodies that lesson. It doesn't aim to be loved. It aims to be relied upon. There is also something quietly honest about a project that understands its role. Chainlink doesn't try to replace everything. It doesn't claim to be the future of money, identity, or society. It simply says, if smart contracts are going to matter, they need accurate information, and someone has to take responsibility for that. Taking responsibility is not glamorous. It means thinking about worst-case scenarios instead of best-case marketing. It means preparing for attacks instead of celebrating adoption numbers. It means building systems that work when incentives are misaligned, not when everyone behaves nicely. Chainlink's design choices reflect a maturity that is rare in an industry still discovering itself. On a more personal level, Chainlink also serves as a reminder of how value is created over time. Not through constant excitement, but through repeated reliability. Not through visibility, but through necessity. Many people only notice infrastructure when it fails. Chainlink's greatest success may be how rarely it gives people a reason to notice it at all. That kind of success requires patience, both from builders and from observers. In a space obsessed with speed, Chainlink moves deliberately. In a market addicted to narratives, it focuses on standards. In an industry that often confuses speculation with belief, it anchors itself in utility. Watching this unfold challenges the way we evaluate projects, and in some ways, the way we evaluate our own decisions. Because Chainlink asks an uncomfortable question: are we drawn to what is essential or to what is exciting? The more I reflect on Chainlink, the more it feels like a mirror. It reflects a version of crypto that is less about dreams and more about responsibility, less about disruption for its own sake, and more about building systems that can be trusted to behave correctly when no one is watching. This doesn't mean Chainlink is perfect or beyond critique. No system is. But it does mean that it represents a category of value that is easy to overlook and hard to replace. The kind of value that only becomes obvious when the stakes are high and the margin for error disappears. In the end, Chainlink is not a story about a token or a protocol. It is a story about restraint, about choosing to solve an unglamorous problem because it needs to be solved, about understanding that the future is not built only by visionaries, but by those willing to do the quiet, necessary work. And perhaps that is the most important lesson Chainlink offers, not just to the crypto world, but to anyone trying to build something that lasts.